Okay, right. What we are now going to touch on there, it is the subject of thermodynamic laws. Let's just write that down there. Thermodynamic laws. Okay, right. Let's just say there 1.2. Thermodynamic laws. Okay. Now, okay. There are a range of thermodynamic laws. What do we mean when we say a range? A range simply meaning there's more than one. Okay, so when we say laws, let's write some suggestions or proposals for what it entails, meaning what it includes. Okay, the first that we are going to talk about is something called Joule's law. Joule's law. Okay, that's the first one. Okay, the second one is Clausius's theory. Clausius's theory. Okay, then also we have Boyle's law. Okay, right. Then we also have Charles's law. And then the other one, it's basically what we refer to as the specific heat capacity of a gas. Specific heat capacity of a gas. Okay. Specific heat capacity of a gas. Right, specific heat capacity of a gas. Okay, so these are the 5 constituents of what make up what we refer to as thermodynamic laws, at least in this instance. Maybe there are more, I don't know. Okay, but for now we are dealing with this 5, right? So okay, so let's just go and then touch on Joule's law. Simply meaning, when we are talking about Joule's law, what exactly is it that we are talking about now? The first law of thermodynamics, it is a version of the law of conservation of energy adapted for thermodynamic systems. The law of conservation of energy states that the total energy of an isolated system is constant. Energy can be transformed from one form to another, but it cannot be created or destroyed. The first law is often formulated by stating that the change in the internal energy. Now let's write that down. Yeah. The change in the internal energy. Okay, a change in the internal energy of a closed system is equal to the amount of heat to the amount of heat supplied to the system. Okay, minus the amount of work done, minus the amount of work done by the system on its surroundings. Okay, right, so that's the phraseology. Okay, simply meaning Joule's law, the change in the internal energy, meaning there's an internal energy, and that internal energy, it is now changing. The internal energy of what? Of a closed system. Okay, it is changing. Okay, there's a change in the internal energy of a closed system, and it is equal to the amount of heat supplied to the system, simply meaning there's heat going to the system, heat being supplied to the system, minus the amount of work done by the system on its surroundings. So there's a change in internal energy. Now that change in internal energy, it's because of a function of two things: heat supplied to the system, and then you have the amount of work done by the system on its surroundings. So because of the work done of the system on its surroundings, it is essentially losing heat. And then basically speaking, there's also heat being supplied to the system, and then there's that slight variation in that internal energy, and then that is referred to as Joule's law. Now let's try to write it down in mathematical terms. Okay, right, let's try to write this down in mathematical terms. We are going to say there's a change in U, and that is equal to final minus initial. And then another way of writing out final minus initial is simply by saying Q minus W. Now when we say Q minus W, okay, right, let's quickly just define Q. Q is defined as mass Cp, and then T2 minus T1. Okay, now let's just describe what it is that we are saying over here. When we are saying U final, when we are saying U initial, essentially speaking, we are talking about the internal energy. Okay, right. That is internal energy. Okay, internal energy final. Initial, final and initial. Okay, right. Then also let's go further. Now when we are saying a change in U, okay, change in U, essentially we are saying a change in internal energy, simply meaning it is still a change in internal energy. Okay, right. And then also we have Q. Q just refers to heat. Okay, also we have W, and then W just refers to work. Now when we say heat, it's heat supplied to the system. When we are saying W, W is the work done by the system on the surroundings. So now just for this to make sense, the change in internal energy, it is equal to the final internal energy minus the initial internal energy. Okay, however, another way of phrasing it is by saying the heat supplied to the system minus the amount of work done by the system on its surroundings. Now when we are talking about heat supply to the system, this is another way of defining mathematically the heat supplied to the system. It is with this equation over here. Okay, right. Now looking at the formula, when the system gains heat, simply meaning there's an increase in Q. Okay, so now Q is increasing. Why? Heat supplied is what? Increasing. Okay, right. When the system gains heat, Q is positive, and when it loses heat, Q is negative. Okay, when the work done by the system. Né? When work is done by the system, simply meaning your system, it is doing work. The W, it is positive. And when work is done on the system, W is negative. Okay, so let's define that. Let's write that down. That's critical. Okay, for now what we are going to do is we are going to do the following. Okay, we are going to say Q over here. Okay, right, let's do this. Let's say Q. Okay, and then let's say W. Right, Q and W. Now, positive Q. Positive Q. Okay. It means the system is gaining heat. System gains heat. Q is positive. Okay. A negative Q it means the system loses heat. It's losing heat. Okay, the same way here we are going to say W positive. This is work is done by the system. Okay, if work is done by the system, then our W, né? Yes, then our W is positive. Okay. Also, when work is done on the system, okay, when work is done on the system is associated with negative. By the system, it is associated with positive. The same way here, the system is gaining heat, positive. The system is losing heat, negative. Okay,